Hi everyone. In today's lecture, we are going to see what is DSB-SC modulation and demodulation, and we are going to execute this experiment using MATLAB. Before going to this DSB-SC modulation and demodulation, so why the DSB-SC modulation is used instead of amplitude modulation? We'll discuss later on. We'll discuss about DSB-SC modulation and demodulation, and further we will implement using the MATLAB the same uh, experiment. So before going to that, what is happening with the amplitude modulation process? So in amplitude modulation, so the modulated wave consists of three signals, that is a carrier wave and two sidebands. We have two sidebands and one carrier wave. So this modulated wave has information only in the sidebands. That means here in the lower sideband as well as in upper sideband. So there is no information which is contained in your carrier. So the transmission of the signal which contains a carrier along with the two sidebands, what we call it as double sideband full carrier, or simply DSBFC. So why the carrier is not requirements? It has no information to be transmitted. So let us see now. So in DSBFC, the transmission is this DSBSC transmission is inefficient because 2/3 of the power is getting wasted in carrier, which carries no information. That means as along with your lower and upper sideband, we are transmitting a carrier. So the carrier is not having any information. So power is getting wasted. That is 2/3 means 66.6% of the power is getting wasted only to transmit the carrier along with your two sidebands. So if that carrier is suppressed and the saved power is distributed to the two sidebands. So what we are doing in DSBSC, the carrier is suppressed and the power is distributed among the two sidebands. Such process what we call it as a double sideband suppressed carrier, or simply DSBSC. That means only we are transmitting the lower sideband and the upper sideband. So your carrier is getting suppressed in your DSBSC. Let us see how to implement the DSBSC. So here, if you look into the DSBSC, here, as we know the definition of amplitude modulation, so the carrier wave is varied in accordance with your message signal. So to implement the DSBSC, we require a message signal that is having an amplitude AM and having a frequency FM. And here we are considering the phase to be 0. What is that? Phase to be 0. And similar way, we want a carrier to be modulated in accordance with your message signal. So we are considering C of t is equals to AC 2 cos, cos 2 pi FCT, where FC is the carrier frequency. And here also, we are assuming the phase to be 0. And where AC is your amplitude of your carrier and FC is your frequency of your carrier. When the wave is modulated, that is S of t, the modulated wave S of t is nothing but M of t into C of t, that is AC cos 2 pi FCT. So simply, if we multiply message signal with your carrier signal, we are going to get the DSBSC modulated wave. So expanding this, we have AC into AM cos of 2 pi FMT into cos of 2 pi FCT. So by applying the formula cos A cos B, we'll have half of ACAM cos of 2 pi FC minus FM plus half of AC AM into cos of 2 pi FC plus FM. So that means it has only one lower band and the upper side band. So here in this equation, we have eliminated the carrier, which is wasting the power. So how we are going to implement this one? So if you look into the DSBSC modulation, So here, what we do is we are taking a product modulator. So as we have said, S of t is equals to M of t into C of t, for which we are giving a baseband signal or your message signal M of t and a carrier signal C of t to a product modulator to give the DSBSC modulated wave, that is S of t is equals to AC M of t into cos 2 pi FCT. So this is how, when we use a product modulator, we'll be getting the output as your DSBSC modulated wave where your carrier is getting suppressed. So here we have a message signal, carrier signal, and the output looks like this, where there is a phase reversal in your DSBSC modulation. So this is the output what we are going to get when we are doing the product modulation of your message signal and carrier signal. So what we term it as your double sideband suppressed carrier. Let us see how the demodulation process takes place. So whatever the modulated wave which is transmitted, that when it is received on your receiving end, you at receiver, this modulated wave is given to the product modulator, and a carrier wave is also given to your product modulator. And here the phase of your DSBSC wave is should be same as that of your, sorry, the phase of your carrier wave should be same as that of your DSBSC wave which is received at your receiver. When they are given to your product modulator, we will be getting a modulated wave, that is DSBSC modulated wave, which after passing through a low pass filter, we will be getting the actual message signal or the original information signal whichever we have transmitted. So at transmitting end, we are doing the modulation. At receiving end, we are doing the demodulation process. But after demodulation process, we are passing it through a filter. In the same way, now we are going to implement this one using the MATLAB. Let us proceed for the MATLAB experiment. So here, as we have already said so many times, like the DSBSC modulation process. So whenever you open a MATLAB, so normally we write a close all, clear all, and CLC. So this close all, clear all, and CLC, that will close all the open figures, clear all the variables from the workspace, and clear the command window also. So definitely we need to write close all, clear all, and CLC. After that, as we said for the DSBSC modulation and demodulation, whenever I want to pass some information, I want a message signal, and moreover, I want a carrier signal. So what are the parameters we require to set up? So that we are defining, as we know that M of t is equals to cos AM cos 2 pi FMT requires your amplitude of your message signal and frequency of your message signal and a parameter t. And moreover, when I want to have a carrier, the amplitude of carrier is defined, the frequency of your carrier is also defined. So what is this time? So here the time is defined as the initial time, we are taking it as 0, and the interval is 0 to 0 0.01. That is, the time vector is from 0 to 1 millisecond with a step of 1 microsecond. That is how we are defining your time vector. And so after defining all the parameters, next what we do is we define or we generate the message signal. We generate the message signal. So here the message signal is defined as M of t or M underscore t, or simply you can take a variable M. So which is Vm into sine of 2 pi FMT. So we are defining our message signal and carrier signal in terms of sinusoidal wave. Either you can take cos of 2 pi FMT or sine of 2 pi FMT. And carrier wave also, we have defined the amplitude as Vc, and we have defined the frequency as your Fc, and already we have defined the time. So we are taking it as Vc sine of 2 pi FCT. So here also you can use the cos. Both are sinusoidal waves. So message signal and carrier signal, are generated, once they are generated, then what we do is we'll be going for the plotting of your message and carrier signals. So for that, in previous lectures also I said, like if you want to plot the figures separately, there is a predefined function called as figure that you can use to get all the figures like message signal, carrier signal, modulated DSB-SC modulated wave, and demodulated wave separately. We can use the predefined function figure. Here I am using a subplot 4 comma 1 comma 1. So what does it mean? Means 4 comma 1, it represents 4 rows within a single figure. 4 rows we are taking. In that first row I am plotting t comma m underscore t. That is nothing but plotting your message signal. So I am plotting my message signal in this one. So later on, subplot 4 comma 1 comma 2. So what I am plotting here, I am plotting the carrier signal C of t, or C. So that carrier signal, so title represents, the title will be displayed along with your signal if you are using the function title. So in 4 comma 2, that is 4 comma 1 comma 2 represents the second row in 4 by 1 matrix. So there I am plotting my carrier signal. So once plotting of your message and carrier signal is completed, then I go for plotting of your modulated signal. So instead of plotting, before plotting also, or after defining this plot, or simply first also, you can generate what we say, the modulated signal S of t is equals to the product of your message signal into your carrier signal, that is DSBSC modulated wave. So first you can write this equation, later on also you can write it as subplot 4 comma 1 comma 3. That means in the third row of the matrix I am plotting my DSBSC modulated wave. So here we are using a predefined function to plot the positive half and negative half of your message signal. So plot a t comma s of t. Already we have plotted the DSBSC wave, and plot, hold on, means on the same image we are plotting t comma, that is m of t, that is message signal. Which message signal this is? Positive half of your message signal I am representing in red. I am representing in red color. This colon represents the dotted line. So R colon represents, we want to plot the positive half, this positive half in dotted line, that too in the red color, and plot t comma minus m of t comma r, that plots your negative half of your message signal, and hold off is a function. After plotting that, it will come out of that particular figure. So hold on will hold on the same figure, hold off will come out of the figure. Now next what we have is the demodulation process. So in the demodulation process, already we have said that the modulated signal multiplied or given to your product modulator along with your carrier, the condition is that the phase of your carrier and the phase of your modulated signal should be same. So when we give it to the product modulator, a wave which is generated, that is called as demodulated wave, which is having some unwanted signals, one that is passed through your low pass filter. Why only low pass filter means? So I want only the low frequency signals, which is my message signal is a low frequency signal, that is to be allowed and remaining to be rejected. So we are passing through a low pass filter to get your original information signal back. So for that, what we are doing is your demodulated signal R of t is equals to S of t, that is modulated wave, into your carrier wave we are doing to generate your DSBSC demodulated wave. Once this is generated, as we have said that we are passing through a low pass filter. So here I am using a Butterworth filter of order 1 with normalized cutoff frequency, that is 0.01, and that what we are doing, that applying the filter B comma A comma R. What is R? R is you are applying the filter to your demodulated wave. So MR is the actual message signal what we are getting after passing through the filter. So that where we are plotting 4 comma 1 comma 4. That means I am plotting here in the fourth row DSBSC demodulated wave, and plot T comma MR. We are not plotting R, we are only plotting MR, that is which is after passing through your Butterworth filter or filter which is having an order of 1. So when we pass through that one, that information or that signal only we are plotting. So title, already we said that title will be displayed along with your. Now let us proceed how to implement the same code using the MATLAB, whether we are going to get the demodulated wave, whether we are going to plot the message signal, whether we are going to plot the carrier signal, DSBSC modulated wave and demodulated wave. We will see practically by implementing using the MATLAB. Okay, so now already I have copied the code into a notepad and kept it ready. So in this code, or the parameters, whatever the code, whatever I have explained over there, the same thing, the message signal, carrier signal, and your plotting of your signals, and how to plot your modulated wave, everything is I have copied in the same program here. Just now I'm going to copy this program into your MATLAB. So the program is copied here. So what are the titles we have mentioned, or what are the way we have explained? The same thing we have uh, written in this MATLAB program. So now I am saving the program here. Before running the program, we need to save the program. So I am saving this one as your experiment number 3. So once the program is saved, just press the run button. Now you can see the wave output. So the modulated wave. So whatever we have plotted. So as we have plotted in the 4 comma 1 comma 1 the message signal, and a 4 comma 1 comma 2 a carrier signal, and a third one is nothing but your DSB-SC modulated wave. I think the title is missing here. So this is the modulated wave, and fourth one is your demodulated wave. What is nothing but the actual information what we have transmitted. The same we are able to retrieve it back. So this is how we are going to implement the DSBSC modulation and demodulation technique using your MATLAB. Thank you.